All right, welcome back, everyone. If you're a focused learner looking to completely demystify the Cambridge IGCSE Mathematics 0580 syllabus, you are in the exact right place. Today, we're unpacking topic 4, which is geometry. Now, I know geometry can sometimes feel like this massive, overwhelming list of rules and theorems, but we're going to map out the entire core and extended toolkit right here. We're taking that massive list of syllabus objectives and transforming it into a clear, visual roadmap that you can actually use to secure those top marks. So grab your notes, get focused, and let's dive into this. We're going to see exactly what you need to know to master these geometric principles and completely own your next exam. Okay, here is our structured learning path for today's explainer. We've broken it down into 5 key stages. First up, we'll start with a little context in Section 1, the Greek Masters of Math. Then we'll move straight into the practical stuff with Section 2, building blocks, focusing on your essential geometry vocabulary. From there, we tackle Section 3, similarity and congruence, a huge area for examiners. Then we'll map out Section 4, the rules of symmetry, and finally, we will conquer the boss level in Section 5, advanced angle properties. This is the exact sequence you need to build a rock-solid foundation. Let's get started. Section 1, the Greek Masters of Math, or what we call the Golden Age. Now, before we start calculating angles and drawing arcs, we really need to appreciate where all of this comes from. I mean, the geometry we're studying right now, it wasn't just invented yesterday to torture you on an exam. It was forged during an incredible golden age of mathematics by absolute pioneers from ancient cities, places like Ephesus, Miletus, and Alexandria. Understanding that this is the mathematical DNA of our world actually makes it a whole lot cooler to learn. When you trace this timeline, it's actually staggering. These ancient mathematicians were so incredibly far ahead of their time, they essentially wrote the curriculum that you and I are still using today. Think about it. Thales of Alexandria was literally predicting eclipses and inventing the 365-day calendar using these exact principles. Eudoxus was working with pi and discovered the formula for the volume of a cone way before calculators even existed. And Euclid, the guy wrote a book that became the standard university textbook for 2,000 years? Before we continue to our next genius, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, and then there is Archimedes, who lived from 287 to 212 BCE. He is widely accepted today as the greatest mathematician of all time, period. But here is what's fascinating and honestly a little bit tragic. His influence was actually pretty limited during his own life. Why? Because his contemporaries simply lacked the mathematical understanding to grasp his advanced geometry. He was basically playing 3D chess while everyone else was figuring out how to play checkers. The stuff he was visualizing in his head is the exact same high-level geometry you need to master for your extended papers. And if you're wondering, why does this matter to me today? Well, just look at modern glass and steel architecture. It brilliantly illustrates why Archimedes' work and the work of all those ancient Greek masters is still absolutely crucial. The intersecting lines, the acute angles, the structural integrity of those massive geometric beams holding up skyscrapers, it is all governed by the exact same ancient principles. We are literally still building our modern world using the Greek geometry toolkit. When you solve these exam questions, you're doing the exact same math that builds cities. With that historical context in mind, let's shift gears and move to Section 2, building blocks, geometry vocabulary. We're transitioning directly into the 0580 syllabus objectives, E4.1, E4.2, and E4.3. This is where we establish your core terminology and your construction skills. If you don't know the language, you can't play the game, right? Consider these concepts your absolute minimum toolkit. We need to instantly recognize and interpret terms like parallel, perpendicular, bearings, and you've got to know the difference between acute, obtuse, and reflex angles without hesitating. We also need the vocabulary for 3D shapes and their flat 2D nuts. But listen closely, because here is the most critical takeaway for your exam regarding construction. When they ask you to build a triangle given 3 sides, you must use a ruler and a pair of compasses only. No protractors for this specific task, none. The examiner's goal is to see those clear, precise compass arcs proving your construction. If you just sketch it or measure the angles, you lose the marks. Leave the arcs on the page. Now we shift our focus to Section 3, similarity and congruence. This covers syllabus points E4.4 and E4.5. This is all about distinguishing between shapes that just look alike versus shapes that are mathematically identical. Examiners love testing this because it separates the students who guess from the students who truly understand the properties. Let's compare these two concepts directly. Similar figures are essentially like taking a shape on your phone and zooming in or zooming out. The angles stay the exact same, but the side lengths change proportionally. For similar figures, we calculate those scaled lengths, we use relationships between the areas of similar triangles, and we even extend that to the volumes and surface areas of similar solid 3D shapes. Congruent triangles, on the other hand, are exact clones. Same angles, same exact side lengths. No zooming allowed. They might be rotated or flipped on the exam paper to confuse you, but they are identical. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. So, the crucial point for the exam is knowing exactly how to prove that two triangles are those exact clones. You can't just write down, they look the same. You have to use one of 4 specific basic congruence criteria. First, SSS, side, side, side. That means all 3 sides match perfectly. Second is ASA, angle, side, angle. That's 2 angles and the included side between them matching. Third is SAS, side, angle, side, which is 2 sides and the included angle matching. And finally, RHS, right angle, hypotenuse, side, specifically for right angle triangles where the hypotenuse and one other side match. Memorizing these 4 steps is the absolute key to locking down these geometric proofs. Moving right along to Section 4, the rules of symmetry. Here, we're exploring Objective E4.6, which investigates symmetry in both 2 and 3 dimensions. This is another area where visualizing the shape in your head is going to score you major points. For standard shapes, we need to recognize basic line symmetry, which is just where you can fold a shape in half perfectly, and rotational symmetry. A really crucial detail here that trips people up is calculating the order of rotational symmetry. That's simply how many times a shape looks exactly the same as it spins through a full 360 degrees. Don't forget that. We also have to apply this to 3D objects. You need to specifically recognize the planes of symmetry and rotational properties of prisms, which include cylinders, and pyramids, which includes cones. Practice visualizing slicing these 3D shapes right down the middle. Now, what's really interesting about these circle properties is exactly how examiners test them. The syllabus lists 3 very specific rules. First, equal chords are always the exact same distance from the center. Second, if you draw a perpendicular bisector of any chord, it will always pass exactly through the center of the circle. Third, if you draw 2 tangent lines from a single point outside the circle, those 2 lines will be perfectly equal in length. On the exam, they won't just give you one rule. These 3 symmetrical truths are almost always combined into one massive, complex spiderweb diagram. But if we isolate them mentally, the puzzle falls apart easily and you can grab those marks. And that brings us to the big one. We have finally arrived at Section 5, Advanced Angle Properties, Objective E4.7. This is the biggest, most complex arena of the entire topic, where literally all of our previous rules combine. This is where the extended paper really tests your mettle. Consider these basic angle calculations your necessary warm-up. Before tackling the advanced circle concepts, it absolutely helps to be incredibly fluid with these basics. We need to remember instantly that angles at a point add to 360, angles on a straight line add to 180, and exactly how alternate and corresponding angles work inside parallel lines. You know, the z-angles and f-angles. Gaining total, undeniable command over the interior and exterior angle properties of both regular and irregular polygons means we are completely ready for the main event. You can't build the roof if the foundation is shaky, right? All right, here is your core circle theorem toolkit. You need these memorized. First, the angle in a semicircle is always a right angle, 90 degrees. Second, the angle between a tangent and a radius is also always exactly 90 degrees. Third, if you have an angle at the center of a circle, it is always exactly twice the size of the angle at the circumference, provided they are standing on the exact same arc. And finally, angles in the same segment are equal. They like to call this the bow tie shape. Notice the brilliant logical flow here. We're moving from fixed 90-degree rules to proportional rules based entirely on where the angle sits in the circle. Let's see how this builds into the absolute top-tier final exam questions. The first principle points to cyclic quadrilaterals. That's a 4-sided shape where all 4 corners touch the circle's edge. The golden rule? Opposite angles are supplementary, meaning they add up to exactly 180 degrees. And then there is the granddaddy of them all, the alternate segment theorem. This connects the angle between a tangent and a chord directly to the angle in the opposite segment. Mastering these 2 specific theorems unlocks the absolute deepest, most rewarding parts of O580 geometry. This is where you separate yourself from the pack. We've covered an immense amount of ground today, all the way from the golden age of Greece to the exact congruence criteria needed for your modern math exam. Euclid literally wrote the book on this 2,000 years ago, creating a mathematical blueprint that still holds up the modern world. The question is, are you ready to take these ancient blueprints and confidently apply them to your exams? Mastering geometry isn't just about passing a test, it's about seeing the hidden architecture of the universe. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Thanks for exploring with the explainer, and I'll see you in the next one.